हेलो इंडिया लर्निंग सेंटर में आप सबका स्वागत है। नाउ वी विल कंटिन्यू exercise on electric charges and fields, and this is the exercise of NCERT textbook, question number 1.18. So in this questions there is a point charge, there is a point charge 2 microcoulomb. So here is a point charge is this is a point charge 2 microcoulomb. So we have to find out electric flux passing through a cube, through a face of a cube. So if I make a cube here, so this is a cube whose side is a 9 centimeter. 9 centimeter the edge of this cube. A charge is placed inside at the center of this cube, which is 2 microcoulomb. If I place the charges inside of this one 2 microcoulomb, so what is the flux through the passing through the one face of this cube? So using the Gauss's law, by Gauss's law, electric flux is equal to phi E, the electric flux is equal to total charge inside of this Gaussian surface. So we suppose this is a Gaussian surface, total charge inside of the Gaussian surface divided by epsilon naught. This is our formula. So the charges inside of this Gaussian surface, it means that total flux, all the six faces of this cube is equal to this one. The flux passing through one face is equal to, just divide 6 by this, we will get the flux through one face. The flux passing through one face will be 1/6 of the total flux passing through all faces of this cube. Putting the value of charges inside of this Gaussian surface inside of this cube is 2 micro. Micro means 10 raised to the power minus 6 and 6, and epsilon naught value. Either you have to put the value of 8 point epsilon naught is equal to 8.85, 10 raised to the power minus 12, or put the value of 1/, from here 1/45 epsilon naught, 9 into 10 raised to the power 9 Newton meter square upon coulomb square, and its a unit is C square upon Newton into meter square. This is the value of epsilon naught. So it means that it is here, if I place ये value रखने से there is difficulties in calculations. So if I put 1 upon epsilon naught from here, it is easier to solve this one. 1 upon epsilon naught 4 pi times of 9 into 10 raised to the power 9 Newton Newton meter square divided by coulomb square. So now here is epsilon naught. We will put this value for the calculation point of view. So now it becomes 2/6, 2 into 10 raised to the power minus 6 divided by 6, and 1 upon epsilon naught has the value this one, 4 pi 10 raised to the power 4 pi into 9 is also 4 pi into 9, 10 raised to the power 9. So this is the flux passing through one phase. Now it's a unit. You know that electric flux is equal to E dot ds. E dot ds. E had the unit Newton per coulomb. Newton upon Coulomb, and ds has the unit meter square. So this is a unit of this one. If you simplify this one, 3 and 3, and then finally value comes out 4 pi, 4 pi into 3, 4 pi into 3, 10 raised to the power minus 6 plus 9. Minus 6 plus 9 will be plus 3. Now again simplify this. 4 into 3 point, pi has the value 3.14 into 3, 10 raised to the power 3. Now finally it comes out approximately but 12 times of 3.14 and into 10 raised to the power 3. Now it's a value 12 into 4 48, 12 over 1 and 16, carry over 1, but it's a 37. Now this is the value, into 10 raised to the power 3, right in the standard format 3.76 approximately, and 10 raised to the power 4, and it's the value Newton meter square divided by Newton meter square divided by C. This is the value of the electric flux passing through any one face of this cube. Now in these questions, question number 1.19, a flux passing through minus 1, 10 raised to the power 3. So we have to find out the flux if the radius of this spherical surface is doubled. Here radius is in this case 10 centimeter the radius. If I double the radius of the spherical surface, what will be the flux one? So here flux will remain the same because its reason is electric flux from the Gauss's law. Gauss's law says that electric flux is equal to phi electric flux is equal to charge divided by epsilon naught. So so charges inside of this one, if I there should be a charges inside of this one. So since flux is a negative, flux electric flux is negative, so charge should be minus negative minus, because electric field lines goes inside of this one. Our electric field lines, here the electric field lines of this cube will be uh, inside of this one, and these are the electric field lines, and here its area vector will be outside. Area vector is going to outside, ds vector is outside. Angle between E and ds is 180 degree, that's why the flux is negative. इसका flux इसीलिए negative है. So so if I double the radius, अगर spherical surface का radius 20 सेंटीमीटर हो जाता है, so तो flux भी इतना ही रहेगा as the earlier case. Its reason is that charges inside of the spherical surface is not changed. The charges inside of the spherical surface is the same, so that's why the flux, if I double the radius of this spherical surface, will remain the same by these rules, by the Gauss's law. Electric flux is equal to charge inside of the Gaussian surface divided by epsilon naught. So here in this case charge the same, charge is the same inside of the spherical surface. So electric flux will be the same one, minus 1.0 10 raised to the power 3 Newton meter square divided by C. So this is the A part of our question. Now second part, what is the value of the point charges. What will be the value of these point charges which is inside of this Gaussian surface? Now in the second part, we will do by using the equation number first. In this part, charge inside of this Gaussian surface will be Q is your electric flux into epsilon naught, phi E into epsilon naught, and we already know that 1 upon 4 pi epsilon naught is equal to 9 into 10 raised to the power 9 Newton meter square divided by Coulomb square. It is the value of 1 upon 4 pi epsilon naught. So we will use epsilon naught. We have to find out using this epsilon naught goes this side is equal to 4 pi 9 into 10 raised to the power 9 epsilon naught is equal to c square upon just interchange of this one go this side and this go side. So value putting here phi electric flux, we have to put with the sign of the electric flux, which is a minus 1.010 raised to the power 3, and epsilon naught has the value 1 upon 4 pi 9 10 raised to the power 9, and if you simplify this, 4 pi should be 22 upon 7, so minus 10 raised to the power 3 pi at the value 22 upon 7 goes in the numerators, 9 remain here, 10 to the power 9 if I take in the numerator minus 9. So this is the value of this one. Now after simplifying, so the value comes out minus 8.8410 raised to the power minus 9 coulomb. So 10 to the power minus 9, we know that 1 nanometer, 1 nano, micro, nano, 10 raised to the power minus 9. 1 nano means 10 raised to the power minus 9. Now this can be replaced minus 8.84 nano coulomb. So this is the value which will be the charge inside of the spherical surface. Now question number 1.20, chapter 1, question number 20, and this is a conducting sphere and its radius, it is given that at a distance of p 20 centimeter from the center of this sphere, electric field is 1.5 10 raised to the power 3 Newton per coulomb. Inwards, its a direction electric fields toward PO, along PO. Now it's a direction of this electric fields. It means that so what is the charge on the sphere? We have to find out the charge on the sphere. So since electric field is toward the spherical, so charge definitely should be negative on this one. This is a conducting sphere. Total charge remains outside of this, uniformly distributed over the outer surface of this spherical surface. So this is negative charge. This is our negative charge. So here using Coulomb's law, electric field is equal to, we know that electric field is equal to 1 upon 4 pi epsilon naught charge on the spherical body divided by r square. So everything is given. So from here, electric charge on this conducting sphere is equal to E times of 4 pi epsilon naught 4 pi epsilon naught into r square. Now putting all these value, this Q will be, E has the value in SI system 1.5 10 raised to the power 3 and 4 5 epsilon naught if I go this value from here, 1 upon 4 5 epsilon naught has this value, and 4 5 epsilon naught goes in the numerator 4 pi epsilon naught. This is the value and will be 1 upon 9 into 10 raised to the power 9 in SI system. So putting this value here, 45 solenoid and into r square is equal to 20 centimeter, converts into meter, 0.2 whole square and divided by 9 into 10 raised to the power 9. Yes, just simplifying it, 1.5, 0.2 will be 0.04 and 10 ki power 9 goes, if 10 ki power 3 in the numerators and 9 from the denominator, 3 minus 6 divided by 9 divided by 9. Now after simplifying, this value comes out 6.67. If you divide this one, so this value is 6.67, 10 raised to the power minus 9. 6.67 10 to the power minus 9 coulomb. So if I simplify it again, this one, this value is here. Now Q is equal to zero 0.5 into 0.04. It comes out 20 and 3 places of decimals. This 10 raised to the power minus 3 divided by 3. Now removing the decimal, 3 minus 6 is minus 3. Now here remove the decimal here, 20 minus 3 into 10 raised to the power minus 3 divided by 3. यहाँ पर this is 9 should be 9. 3 minus 9 is 3 minus 9 is equal to minus 6. Minus 6, this is minus 6. If you divide 23, it comes out 6.67, 10 raised to the power minus 9. So 6.67, 10 raised to the power 9 can be written as nano. So nano coulomb. This is the value on this conductor. Since electric field lines is from the P point toward the conductor, that's why the charges should be negative. Charges should be negative. Now next question, question number 20. This is a conducting sphere whose diameter is 2.4 meters and the surface charge density is 80 microcoulomb per meter square. Surface charge density has the formula charge divided by surface charge density. Sigma is equal to charge upon area of the spherical surface. So here charge is 80 microcoulomb. Charge 80 micro means 10 raised to the power minus 6 and unit is a coulomb per meter square. So this is the our formula. So now Q upon area and diameter is given 2.4 meter. This is diameter of this one, therefore R will be 1.2 meter. 1.2 meter of the spherical is a conducting surface. So first part in this questions we have to find the charge on the spherical conductor. Now the charge on the spherical conductor will be So charge we will use from here. Charge is equal to density multiplied this one. So charge on the spherical conductor is equal to sigma surface charge density into area of the spherical surface. Area of the spherical surface here, sigma into area of the spherical surface. This is a sphere. Now area would be 4 pi radius ka square, 4 pi radius square. Now putting the value of sigma 80 micro. 80 micro means 10 raised to the power minus 6, and 4 pi r square is 1.2, and its square is 1.2, that is 1.44. So this is the value, simplified this one, 80 into 4 pi, putting the value of pi 22 upon 7, 22 over 7, and 1.2 squaring 1.2 is 1.44. So 1.44. So this is the value charge on this one. If I calculate the value come out simplify this one, 80 into 10 raised to the power minus 6 coulomb. Now if I simplify this one, 22.7 will add the value 3.14, 80 into 4, 22.7 value 3.14 into 1.44. So after calculating this, so this value will be just multiplying all constituent, the value come out 1.45, 10 raised to the minus 3 coulomb. So this charge is a positive, so the charges remains in the outer surface because this is a conductor. So now second part, uh, we have to calculate find the electric flux leaving the surface of the sphere, leaving the surface, because the charges on the sphere is positive charges outer surface, because this is a conductor. If there is not a conductor, then charge will be inside of this volume. Now in second part, we have to find the flux passing through this Gaussian surface, leaving the surface. Electric flux. Now the electric flux is equal to either we use E dot ds, and we will use also Q upon epsilon naught. Q upon epsilon naught. E dot ds, for E dot ds we need to find out electric field on the surface of the conducting sphere, and ds is a 4 pi r square. Area of this is 4 pi multiplied 4 pi r square. So but this, it is better to use this Q upon epsilon naught. If I use this value, it is very easy to solve. Charge on the conductor is 1.45 minus 3 divided by epsilon naught. Now epsilon naught value, as I already discussed, 1 upon 4 pi. 1 upon 4 pi epsilon naught has the value 9 into 10 raised to the power 9 in SI system. So 1 upon epsilon naught has the value 4 pi times 9 into 10 raised to the power 9. Putting the value here, so we will have 1 upon epsilon naught have value, just multiply 4 pi into 9 into 10 raised to the power 9. Now if I simplify this, 1.4 pi into 4 into 9 and this is a pi 22.7, value 3.14, 10 raised to the power minus 3 plus 6. Just adding minus 3 plus 6 is a minus 3 plus 9 is a plus 6. So this is the value. If I calculate, so it value comes out 1.6, 1.6 10 raised to the power 9. Electric flux had the unit Newton upon Coulomb into meter square. Newton divided by Coulomb into meter square is the SI unit of electric flux. So power should be 10 to power 8. So this is the answer. Flux leaving this spherical conductor is 1.6 10 raised to the power 8 Newton meter square divided by Coulomb square. Now in this part of questions, this is infinite line charges. This is infinite line charge, and electric field is given at a distance 2 centimeter from this infinite charged conductor at the point of P at a distance of 2 centimeter is 9 10 to the power 4. We need to find out linear charge density. Linear charge density of this surface. So now the formula is here. We will use the formula. Electric fields for infinite line charge is lambda divided by 2 pi epsilon naught into r. So this is the value from here. Lambda comes out, lambda linear charge density, charge divided by length. This is the formula. Charge divided by length is equal to, here from here, E times of 2 pi epsilon naught. The value comes out E into 2 pi epsilon naught, E into 2 pi epsilon naught multiplied R. So if I calculate this value, now here lambda linear charge density, called linear charge density, linear charge density is equal to E times of electric fields in SI system 9 to 10 raised to the 9 10 raised to the power 4, 9 to 10 raised to the power 4 in 2 pi epsilon naught, 2 pi epsilon naught. So here epsilon naught had the value, epsilon naught is equal to 1 upon 4 pi into 9 into 10 raised to the power 9. We will use here 2 pi. 2 pi has the value 22 upon 7. 2 pi into epsilon naught has the value this one into r. So now the value going in the denominators, epsilon naught 4 pi into 9 10 raised to the power 9. In the numerator, this is r is 2 centimeter, converts into meter, 2 into 10 raised to the power minus 2. So this is the value, and here pi would cancelled and 9 is also cancelled. Finally we have the value 2 to cancel out, 2 and 2 is also cancel out. The value finally becomes, in the numerators we have 10 to the power 4, 2 to 4 and 4 is also cancelled. Finally we have 10 raised to the power 4 and 10 to the power 4 minus 2 divided by 10 to the power 9. This 10 to the power 9 goes also in numerator. So this is the value 4 minus 2 minus 9. So now this value will be 4 minus 2 2 minus 10 to the power minus 7, 10 to the power minus 7, 10 to the power minus 7. We write it like 10 to the power minus 1 into 10 to the power minus 6. 10 to the power minus 1 will be 1 upon 10, 10 to the power minus 6. So this 0.6 and 10 to the power minus 6 will be micro. So 0.1 micro, and unit of lambda will be coulomb per meter. Coulomb per meter. So unit is a coulomb divided by meter. This is the answer of this part. Question number 22. Now the last questions of this exercise is 23. Now in this part of the questions, there are two infinite plate number 1, and this is plate number 2. So there are charges in the inner side of the plate. Inner side means between the face is towards between lies facing towards each other. So it has the positive charge on this one, and so it has a negative charge. The negative charges on this plate is minus. So both have same surface charge density. So we have to find out electric fields in the three region. This is first region in the at the point of A, and between them suppose here B, and it the point at the point of C. These are the three regions where we have to find out electric fields. So electric fields are this infinitely. We know that electric field due to infinite plate is sigma. Electric field is equal to sigma upon 2 epsilon naught. This is the value we have. Sigma is the surface charge density. Both have the same surface charge density. So now this is positive charge electric field due to this one is away from this one. Electric field due to this plate number 1 is along this one. Suppose if I represent this electric field due to first plate E1, and this is negative plate. Electric field due to negative plates is toward the negative plate. So it has the value E second plate. Since both have same magnitude, E1 and E2 both have the same magnitude. E1 and E2 both have the same magnitude. They also in opposite direction. So net electric field at this point will be 0, because sigma upon 2 epsilon naught minus sigma upon 2 epsilon naught. The value come out 0. This is the first regions toward the outer side of the first plate. Now we have to find out at the point of B. At the point of B, electric field due to the first plate is this is a positive charge on this one. Electric field due to this is away from this one. So electric field due to the first plate is E1, and this is a negative plate. Electric field due to the negative plates going toward the negative plate. So second plate also have the same direction. So since both have the same direction, so they have the same magnitude, so resultant electric fields will be cancelled out. Cannot resultant electric fields will be added. So now at the point of B, to resultant electric field, we have E is equal due to first plate and due to the second plate, and putting the value sigma upon 2 epsilon naught and plus sigma upon 2 epsilon naught. The value come out sigma upon epsilon naught. So this is the value of sigma. This is the value of sigma. Sigma is equal to 17 into 10 raised to the power minus 22 divided epsilon naught. We will utilize here the value of this one, 1 upon 4 epsilon naught into 9 into 10 to the power 9 Newton meter square divided by Coulomb square. So the value from here 1 upon epsilon naught. So 1 upon epsilon naught has the value 4 times 9 into 10 to the power 9, and the unit will be same 1 Newton meter square divided by coulomb square. If I place the value here, 17 into 10 raised to minus 22, 1 upon 4 pi, 1 upon epsilon naught has the value 4 pi into 4 pi, 4 pi into 9 into 10 raised to the power plus 9. So after simplification, 17 into pi 4 and 22 by 7 into 9, 22 by 7 into 9 into 10 raised to the power minus 2 plus 9 is plus 7. Now if you simplify this one, 22.7 is 3.14, 17 into 4 into 22.7, 3.14 multiplied 9, 10 raised to the power 7. So this is the value of the electric field. This is Newton upon Coulomb. Now its answer come out 19.2, 10 raised to the power 7, and there is some mistake. Sigma is 17 into 10 to the power minus 22. This is minus 22. Minus 22 plus 9 now will be minus 13. Minus 22 minus 13, minus 13. This is minus 13. So the value after multiplication, this 19.2, 10 raised to the power minus 10. This is minus 10, and unit of electric field is equal to Newton per coulomb. This is the electric fields at the point of B, and the direction is from the first plate toward the second plate. Now at the point of C point has a positive charge. This is a positive charge. Its electric field is away from this one, away from the positive plate, and this is negative plate. So electric field will be towards the negative plate T2. Since both are equal and opposite, so electric field at the point of C will cancel out. At C, electric field both are equal and opposite, sigma upon 2 epsilon naught, sigma upon 2 epsilon naught, it is equal to 0. So now the exercise is over on electric field and charges. Since there are some basic questions about the concept, how to apply the formula, and some questions are tricky somewhere. So you have remember these are tricky questions, and do practice again.